Hi everyone, this is another example of solving a problem based on finding the surface area of composite objects. Now, our first step is that we see that two boxes are attached to one another. So our first job is to separate both the objects. So we do that, we draw one box plus another box. These two boxes are making up this two object, right? So this object. So what we have to do, we have to calculate the surface area for the individual objects. Surface area of the smaller box over here and the surface area of the larger box. And then add them up to get the total surface area, right? That will give us the surface area for the object. So now let us do it. Let us check what is happening to the smaller box. Now what we have to do here, we draw the smaller box once again and give the respective dimensions. Here it is 2 and the height is 1 and the width is also 1, right? So in order to calculate the surface area of the rectangular box, we know the formula is surface area equals 2 length times width plus width times height plus height times length. Now the length of the smaller box is 2 cm, the width is 1 cm and the height is also 1 cm. So now we insert this value in this particular formula. As we do that, length times width is 2 times 1 plus width times height is 1 times 1 plus height times length is 1 times 2. As we do that, 2 plus 1 3, 3 plus 2 5, 5 and 2 makes it 10. So the surface area for the smaller box is 10 centimeters square. Now let us see how we can find the surface area for the larger box, and it is again very simple. Just identify the length, width and height of the rectangular box. So in order to do that, let us draw the box again. This time the larger box, as you can see in this diagram, we are dealing with this box over here. So the dimension is 5, 3 and the height of the box is 2. So our first job is to identify the length, width and height. In this case the length is 5 cm, the width is 3 cm and the height is 2 cm. Now we again use the formula for the surface area of the rectangular box, which will be length times width, width times height plus height times length. Now inserting the formula, we see length times width is going to be 5 times 3 over here plus width times height is 3 times 2 plus height times length is 2 times 5 over here. So this will give us 15 plus 6 21 and 10 31 and 31 multiplied with 2 as 62 centimeters square. So this will be the surface area for the larger box. Now we combine both the objects together in order to get the total surface area, right? So combining the smaller box and the larger box, we will add the surface area. So we do that in the next line. So the total surface area would be 62 centimeters square plus 10 centimeters square. And this eventually will give us the result 72 centimeters square. Now we have the surface area for the total object. Now here is the tricky part for the problem. Now we have to check the overlapping area. Overlapping area is that particular area which is connecting both the objects together. So the place where the object is connected together is actually done by this rectangle that I am shading at the moment, as you can see in the diagram, right? You are fixing one rectangular box over another big rectangular box. So the lower bottom part of the rectangular box is actually the connecting part for both the object. So as I said before, in order to find the overlapping area, you always have to do one important thing, is multiply with 2. All the time there should be a multiplication with 2. And why we use 2? Because this part is connected to both the objects, the smaller rectangular box as well as the larger rectangular box. So there shall always be 2 multiplied with the area which is involved in overlapping. So we see that it is a rectangle which is involved in overlapping, and the dimension is 2 centimeter as the length and the width is 1 centimeter. So we write length times width, and we do the problem. Length is 2 multiplied with 1 and we get 4 centimeters square. Now if the overlapping area was not a rectangle but rather a circle like this is an overlapping area for an object like this, what we would do, instead of using length times width, we should be using pi r square. But remember, the 2 will always have to be multiplied. If it was a triangle, we would have used base times height divided by 2. So basing on the shape that the overlapping area is creating, we have to figure out which formula to be used over here and multiply by 2 each time, because the overlapping area is present in both the cylinder as well as the box, or the box over here and the box at the bottom. So our final job is to subtract the overlapping area from the total surface area that we have found. So it is very simple, and this will give us the total surface area of the composite object. So the total surface area of the composite object, and we can write it as 72 centimeters square minus 4 centimeters square equals 68 centimeters square. So this is how you can calculate the surface area of composite object. Hope you enjoyed the video and had learned how to find the surface area of composite object. Thank you, and thanks a lot for watching the video.